Okay, so what have we learned so far? We have learned how to come up with the formula of ionic compounds. And okay, by the way, this is on page 53 of your theory book. Okay, we have learned how to come up with the formula of ionic compounds, and this is predicted by balancing the charge on the ions. So an example is if I have magnesium chloride, I have Mg2 plus and Cl minus. Looking at the charge and we cross them, the formula will be MgCl2. Another example is if I've got magnesium nitrate. So this is when I'm using polyatomic ions. And if you look at the charge and you cross them, I will end up having two sets of nitrate ion. So this is when I need to use brackets, and this is how I get the formula Mg bracket NO3 2. Okay, so under ionic compounds, you need to look at the charge, cross them, know when to use polyatomic ions, and also know when to use brackets. For covalent substances, I have two types of covalent substances. One is using prefixes. So an example of this is carbon dioxide, okay, where I have the prefix di inside the name of the formula. Okay, so the word di over here. The second way is that you have to memorize, because you cannot determine the chemical formula from the name of the chemical. So an example is ammonia, and the formula is NH3. So there is no way I will know that there is a nitrogen and 3 hydrogen inside a molecule of ammonia from the chemical name itself. So for covalent, sometimes it is a little bit more difficult. So let us move on now to elements. Elements in your periodic table, you know that there are two types, one metal and the other one non-metal. For metal, it is very straightforward, because if let's say I'm looking at iron, okay, let's say I'm looking at iron, and let's say I have a block of iron. In this block of iron, it is all made up of iron atoms. How can I know how many iron atoms there are inside a block of iron? Right? I cannot count how many there are. And it doesn't make sense for me to write Fe 1 billion. And I don't know how many zeros there are in 1 billion. Right? It doesn't make sense. So the way to write the formula of iron is just Fe. Okay, so it is just Fe. So just if let's say I've got aluminium, and the question tells you aluminium foil, the formula will just be the symbol Al. Okay, for metals, it is very straightforward. You just have to use the formula in the chemical, what you see in the periodic table. For non-metals, it depends on the bonding present, right? Like what you see over here, it depends on the bonding present. So some of them may appear as diatomic, some of like Cl2, some of them may be monatomic like Ar, argon, and some of them may have other numbers attached to it. What I'm going to show you is what are some of the common ones that you will see in your questions, and they are actually mostly diatomic molecules. So if you look at your periodic table at your very last page of your theory book, let us write something together that may help you to be able to come up with formula a bit better. Okay, so we were talking about elements. Okay, we were talking about elements. Firstly, I need to be able to distinguish between metals and non-metals. So that's when our dividing line comes in again, right? Find aluminium, and this is our dividing line that breaks up metals from non-metals. Okay, so on the left-hand side are metals, and on the right-hand side are non-metals. For the non-metals, for the diatomic molecules, they are actually mostly these ones. So I'm going to circle them for you, and it might be good for you to write it down in your periodic table as well. So H is an example. This is a diatomic molecule. The formula of this is H2. What are the others? I have N2, O2, F2, Cl2, Br2, I2, At2. So these are all diatomic molecules. And these are the common elements that you will see in your questions. So it might be good to know them right now. Okay, and for some other elements like carbon, typically they are just written as the chemical symbol itself, because carbon is an example of carbon element is diamond, and I can't count how many atoms there are inside a crystal of diamond. So for this, it follows the same reasoning as our iron just now. So this will just be C. The formula of carbon element will just be C. Okay, since we're on the periodic table, let me just fill up with the charge of the ions for ionic compounds as well. Then you will have a complete picture for this. For ions that fall under group 1, because they all have one valence electron, the charge will always be plus. For ions in group 2, they will have a charge of 2 plus. Ions in group 3, 3 plus. Ions in group 5, this will be 3 minus, 2 minus, and minus. Okay, so this is for ions charge. Ionic charge rather. Alright, and I missed out on the noble gases just now. Okay, so maybe let us look at noble gas. For noble gases, we are, you will know that let me choose this. Okay, for noble gases, they already have noble gas configuration. Right, so with the noble gas configuration, they are all stable. So do they undergo bonding at all? They don't. Right, so what will be the formula of the noble gas? It will just be the chemical symbol itself. So if I'm asking you what is the symbol, what's the chemical formula for helium? It will just be the symbol itself, and the formula will be He. Similarly, if I ask you for argon, the formula will just be Ar. Okay, so let's go back to our page in the theory book just now. Okay, let us fill in this portion. Aluminium is a metal. Right, so for metal, it is the symbol itself, so it is Al. Nitrogen gas. This is a non-metal, and it is actually diatomic. It is a diatomic molecule, like what we saw in our periodic table here, diatomic molecule. So the formula will be N2. Okay, let's do the elements first. Copper is a type of metal. So again, same thing. if you look at the periodic table, the symbol for copper is Cu, is not Co, right? Co is here, is cobalt. So it's Cu, and we will write it here as Cu. Krypton. Where is krypton? Krypton is a noble gas over here. So noble gases are monatomic. Right? Noble gases are stable on its own. They don't bond with anything else. They are monatomic, which means there is only one atom inside. Okay, so it will just be Kr. The other two, ammonium carbonate. Okay, ammonium carbonate, this is an ionic compound. So it is made up of two ions, ammonium ion and carbonate ion. So when I cross them, it will be NH for bracket 2, because the 2 was, because the 2 was brought over to the ammonium, and then the other side with 1 being brought over to carbonate, it is just CO3. So formula is NH4 bracket 2 CO3. For barium hydroxide, barium is found in the periodic table here under here. This is a group 2 metal. So as the ion, it forms a charge of 2 plus. So this is Ba2 plus. Hydroxide ion is one of those ions that I have to memorize. So this is OH minus. So looking at the charge and I cross them over, when I put the 2 across to the other side, I will need to have 2 sets of hydroxide ion. So my formula will be Ba bracket OH close bracket 2. Okay, so that's for this portion. Please fill in the blanks in your book.